The objective of our machine was to paint a blue dot on a piece of paper. All of Newton's laws of motion are included in this project, as are the principles of conservation of momentum and conservation of energy. Newton's first law is seen when the hanger glides down the Chinese jump rope and comes into contact with the previously stationary book. The law states that an object in motion will stay in motion, or an object at rest will stay at rest, unless acted upon by an outside force. In this case, the object in motion is the hanger, and it is acted upon by the handle of the stepladder, which causes it to come to a stop. Newton's second law is seen many times in this system, but is best exemplified when the marble at the beginning of the system hits the glue bottle and causes it to fall. Because the marble is rapidly accelerating down a pipe, it has a force which ultimately causes the glue bottle to move. The force of the marble is formed by the relationship between the marble's mass and its acceleration, gravity. The step that illustrated Newton's third law was the marble near the end that rolled down a car track and collided with a toy car. The car has an equal and opposite reaction to the marble. When the marble hits the car with X amount of force, the car hits the marble back with that same amount of force. Since the mass of the car was more than the mass of the marble, the car did not move as fast as the marble did. The presence of both conservation of energy and conservation of momentum can be summed up in saying that the machine never stopped moving. For momentum, both domino effects show conservation as each individual domino transfers its momentum into the next one. Also, when the train begins the domino effect, it shows how momentum is conserved because the train stops moving when it makes contact with the first domino. As for conservation of energy, the energy of the system is obviously conserved because all of the parts move. Negligible amounts of energy are lost due to friction and collision with the non-moving parts of the machine. But since the system still moves and completes its task, you can tell that most of the energy is conserved and continues to power the machine.